So we're going to continue work in section 6.2. Let me remind you a little bit about some stuff that we did in section 6.1. We looked at what was called the standard normal curve. And we worked with areas underneath the standard normal curve. Now, what characterized the standard normal curve, and there's only one of them, is that not only did it have a normal distribution, but it had a particular mean and standard deviation. Does anyone remember what that mean and standard deviation were for the standard normal curve?
0 and 1.
0 and 1.
0 and 1. Well done. Thank you. So 0 and 1. Now with your non-standard normal curves, they can be kind of anything. So let's take a look over at one of the problems in the book. And I'm trying to remember exactly what page this is on. I thought it was on 252. Yeah, let me just switch over to page 252. No, maybe it's 253. One more page. There we go. Problem number 31. The length of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. So let's stop right there and write down some information that we know we're going to need. So this is problem 31. X is distributed normally with a mean of 268 and a standard deviation of 15. Okay, well, let's continue. In a letter to Dear Abby, a wife claimed to have given birth 308 days after a brief visit from her husband, who was working in another country. Find the probability of a pregnancy lasting 308 days or longer. So what they're asking you for is this. Probability X is greater than or equal to 308. Now with a continuous random variable, it doesn't so much matter that we use a greater than or equal to. If this was a discrete random variable like your binomial distribution, then greater than and greater than or equal to would mean different things. But here we can probably get away with being a little bit more sloppy. Let's draw our situation here. So something like this. There's our normal curve. Can anyone tell me what I should label this with along our x-axis? What number goes here?
268.
Thank you, 268. Excellent. We want to try and find the probability that x is greater than or equal to 308. So let's put that here, 308. What region of this curve should I shade, to the right or to the left?
Right.
Yeah, we're going to shade everything to the right. So I want to find the area to the right. Now you've got a couple choices as to how to do that. It kind of depends on what you like. Now one choice would be to use StatDisk. Now I checked with the author, and StatDisk really only works with the standard normal curve. But that's not too big of a problem for us. What we can do is make a little transformation. You might remember this from a little while ago. Z equals X minus mu over sigma. So what we'll do is we're going to build the equivalent problem with the standard normal curve. So I'm going to do that transformation. That's going to give me something in the standard normal curve. That'll be an equivalent problem to finding the area here. So what's that going to look like? Well, this is our Z distribution, normal 0, 1. So that's a 0. Question is, what is this point? We need to calculate it. It's going to be 308 minus the mean divided by the standard deviation, which is 15. So 40 over 15 is 2 2/3, at least according to the mathematician in me. Now, when you work with this in Stat disk, you're probably gonna have to put in some kind of a decimal value, so 2.666, you know, on and on and on until you get bored, and that's fine. Let's open this up in stat disk and see if we can't figure out this probability. So I'll write this down here, 2.66. Yeah, I'll just do bar to make me feel happy. So in stat disk, where you want to go is analysis, and then probability distributions, then over to the normal distribution. So analysis, probability distributions, and then to the normal distribution, which will take you here. Now, depending on the problem, you're going to put in one of two of these. You're either going to put in a z-value or you're going to put in an area. Right now, we're going to be putting in a z-value. That z-value is going to be 2.6666, you know, as many sixes as you want. At some point, you're going to get bored. And let's see what we get. Now, it tells me the z-value, but it also tells me some areas. And we got to think carefully about the area that we want. Do we want the area to the left or to the right or in the middle? Which one do we want?
To the right.
Yeah, to the right. So we want the area in the right tail. So that's going to be 0.00383 equals 0.00383. And so that doesn't seem too bad in terms of a way to calculate that. Well, let's take a look at it with Google Sheets. Now, I think eventually you might warm up to Google Sheets a little bit more than working with StatDisk, because this calculation gets kind of tedious after a while. So the nice thing is that in Google Sheets, you don't have to do this and then look up a number. We can just do it directly from here. Now, Google Sheets works by giving you the area in the left tail. So that is going to be something where you have to think about a little bit as we do our problem. But at least as far as finding the area in the left tail to the left of this point, the command is going to be, now leave a little space here. It's going to be norm distribution of our number, 308, and then the mean, which is 268. The standard deviation is 15, and then true. And let's put that in to Google Sheets and see what we get. So I'll put it in here. There's our command. Norm distribution of 308, 268, 15, true. And that gives me 99.61, et cetera. But if I look back at this, I realize, oh, wait a minute. I expected a really small number, something close to 0, not something close to 1. What's going wrong? What do I need to do?
It's giving you, it's giving you the left, so you would do 1 minus that number.
Exactly. So we need to do 1 minus. Now earlier, I just asked you to leave a little space here. We want to do 1 minus that number to get this. So there's a couple ways you could do this problem in Google Sheets. One of them would be to simply take your answer here, and in the next cell, put equals 1 minus that. Bam. And then you got it. The other possibility is just do it all at once. That's the way I had originally had it done. So if I do it all at once, it'd look like this. Equals 1 minus that. Either way, you're getting the same thing, 0.00383. Nice, nice. So how are we looking on that first one?
Good.
Good.
All right, cool. Let's take a look at the second part of the problem. What does the results suggest? Remember, this is the likelihood that dad came home for a visit, and 308 days later, mom has a baby.
She might have had another kid.
Yeah, it's kind of unlikely. Yeah. I don't know. It's about all I want to say. That is, it's kind of unlikely, so we'll leave it at that. The big part, though, for us is this: is that you're comfortable calculating these probabilities. And sometimes, depending on the software that you're going to work with, you're going to need to do a 1 minus something. That's a possibility. So, all right, let's continue with some more of these types of problems. Is there any one of you young ladies out there in the audience that's kind of tall, wants to check how your height compares to heights of women in general? You'd have to share your height with me, though. Women's heights are distributed normally with a mean of 63.6 inches and a standard deviation of 2.2 inches. So is there anyone out there that's particularly tall, or maybe not so tall? Just want to see how you fit in with this distribution.
I'm 5'7".
5'7"? All right, that's pretty tall. So let's take a look at that. 5'7", that means you're 67 inches tall. So thank you. So X is 67. Let's see what percentile you're in for the height of women. So let me draw the distribution again. Somebody help me out with this middle number. What's that going to be?
0.
63.6.
Oh.
So 63.6, and Lauren was a lofty 67 inches, so that's out here in the right tail. So we can do a couple things. We can figure out the percentage of women that are taller than Lauren, or we can figure out what percentile she's in. But either way, it's going to start out with figuring out how much area is to the left of this curve. So let's do that, or left of this point, I should say, underneath the curve. Now, again, you could do this with StatDisk. Doing it with StatDisk, you would transform this to an equivalent problem in which you would do the Z calculation. Z equals X, which is 67, minus mu, 63.6, divided by 2.2. And that's going to give us a point over here someplace that we can look up with StatDisk. Or we can just do it all directly on Google Sheets. So let's take a look at it in both cases. Let's see here. I need to calculate that. One quick word to the wise: if you're going to do it all in one stroke, you need to use parentheses in the numerator. 67 minus 63.6 divided by 2.2. So we get a z-score of about 1.545. Now, typically speaking, z-scores, you round them off to the nearest hundredth. I put in an extra spot because we're going to be using technology. Let's go back to StatDisk. 1.545. So there's a couple different areas we're getting. One, we're getting the area to the left. So 93.88%, or 0.9388. 9388. And that area is the same for both of these curves, 0.9388. So as a percentile, that's going to be 0.9388. So Lauren, you're taller than about almost 94% of women, coming in at 5'7". That's really good. Let's look at it on Google Sheets. We'll see what you like better. So in terms of Google Sheets, wrong sheet. In terms of Google Sheets, let me put that one here. Make that a 67. So let me write down the command for you first. Will equal norm distribution of 67. So it's your X variable. And then the mean, which is 63.6. And the standard deviation, which I gave you, is 2.2. And then true. So that's the command we need to type in. And we're getting exactly the same thing, 93.888. So nice, well done. One last little reminder using this problem here.
So, I'm sorry to interrupt, but for that number, like in what case would I do 1 minus that number if it was like with the same problem?
Great question. In fact, I'm going to use that idea in just a second here. So hang on.
All right.
So let's remember our Z sub alpha notation. Z sub alpha is going to be the area in the right tail. So that's this area here. That area is going to be alpha. So if I want to figure out what's the area in the right tail, then I would do 1 minus that, and that'll tell me how much area is in the right tail. So let's do that. In fact, you know what? I don't feel like getting my hands dirty on a calculator. I'll just do it this way. So I'll do equals 1 minus, and then I'll click on that cell. Beautiful. Work smarter, not harder, right? There you go. So notation-wise, this would be Z sub 0.061. And that'd be the same thing as this right here. So it's going to be Z sub 0.061. And I'll do 1, 2 maybe. There. So these mean the same thing. The one of them saying that you're in the almost the 94th percentile, because 93.88% of the data is to the left of you. The other one's saying, oh, there's 6.12% of the data that's to the right of you. So it's just a matter of, are you working with the area in the left tail or the right tail? So if I asked how many people were taller than Lauren, then I could say, oh yeah, 6.12% of women would be taller. Rodette, does that help out?
Yes, that does. Thank you.
Okay, awesome, awesome. Let me keep going. Let's see. Now, sometimes you can ask questions that go in the reverse direction. That is, you could say, all right, so Lauren's pretty tall, all right? There's only 6% of women that are taller. But what if we put the standard out a little bit farther? What if we said, you know what? I want to know where the top 2% of women fall in terms of height, or the bottom 2%. What are those numbers? So in this case, you're going to be doing kind of the opposite. You're going to be starting out with an area and then trying to find an X value. So you're no longer going to be using the norm distribution command. You're going to be using the norm inverse command. And I should have an M there. So let me draw what I mean, and then we'll do a couple examples with that. And I think this next set of examples might convince you that, you know, Google Sheets is not all that bad in terms of how you would want to work this. So let me kind of write a problem first. What is the 98th percentile for the height of women? Okay. Well, let's figure that out. Actually, I'll draw it this way. And I'll need another one. So I'm going to show you how you'd have to do it with StatDisk, and then we'll compare that to how you would have to do it with Google Sheets. We're going to use the same distribution here. That X is distributed normally with a mean of 63.6 and a standard deviation of 2.2. So let me put that down here. That's always going to be the line of symmetry for these distributions is the mean. It's also the mode that is the most frequent. And then we're going to also work with the Z distribution here. Z distribution here is distributed normally with a mean of 0 and a standard deviation of 1. And what we're looking for is the point on these distributions that just gives you the top 2%. So this area is going to be 0.02. And I want to find that value of X. Now with StatDisk, we can only find this one directly. We can figure out what that 90th percentile is for the standard normal curve, but we can't figure it out for just any normal curve directly. So what do you have to do? Well, what you're going to do is take our formula Z equals X minus mu over sigma and solve it for X. Now I'll do the algebra for you because I know a lot of you don't really like algebra. It's going to be X equals Z times sigma plus mu. That's how you're going to find this point. Wow. So what does that mean? It means we first of all have to find this point from the standard normal distribution. We have to find the point that puts 2% of the area in that right tail. Well, that we can do pretty easily. Now, 2% of the area in the right tail, that's going to mean 98% of the area in the left tail. If you look at this, it says cumulative area from the left. That's what I got highlighted right here. Cumulative area from the left has to be 0.98. And when I put that into my normal distribution, I get a Z value of 2.05. If you accidentally put in 0.02 by mistake, what you'll see is you're going to get a symmetric point on the other side of the normal curve. You'll get something below 0. And hopefully if you got something below 0, you're looking for something above 0, you realize, oh, I just put in the wrong area, and fix it. Just make it positive. So 2.05375. I don't really need all those digits. But I've got everything I need now. I've got my Z value right here. I've got that. I've got sigma, which is 2.2. And I've got mu, which is 63.6. So to calculate my value, I have to just put all this in. It's going to be 2.053 times 2.2 plus 63.6. Yeah. All right. I mean, doable, not necessarily very enjoyable, but very doable. What about if we use Google Sheets on this? So we use Google Sheets. I'm thinking this is going to be a little bit easier. And when we do Google Sheets, I'll give you this total. I'm just being too lazy to fill that into my calculator. The nice thing about Google Sheets is that you can do this directly. So I'll redraw my distribution. I want to find that point in the distribution with 2% of the area in the right tail. Well, if I have 2% here, that still means 98% here. Let's compare it with Google Sheets to what we just had to go through with StatDisk. With Google Sheets, I'm going to start out with the area, so that means I use the norm inverse command, which gives me area to the left, 0.98, the mean, 63.6, and the standard deviation, which is 2.2. So let's type that in and see how we did. So here's our command. Norm inverse of 0.98, 63.6, and 2.2. So 68.11, we'll call it. 68.11. So if you want to be in that top 2%, Lauren, you just got to grow another inch. You'll be in that top 2%. All right. Just have fun.
One question. When you're using Google Sheets, you don't have to do the z equals x minus mu divided by sigma,
No,
right? Okay.
you don't have to do that transformation. See, the reason we have to do it with StatDisk is because StatDisk only works with the standard normal curve. It doesn't have the ability to work with non-standard normal curves. So you've got to use one of these two transformations. You either got to use this one or this one. So one of those two transformations is going to take you from your standard normal curve to your non-standard normal curve, or vice versa. So this will take you to the standard normal curve. This one will take you back.
All
So
right.
if you're using StatDisk, then you're going to have to use one of those. Well, Google Sheets just does it directly. So I kind of like that better, but it's up to you.
I had a question.
Yes.
So why do we use the 0.98 instead of the 0.02 when we
Good
type
deal.
in Google
It's
Sheets?
because Google Sheets needs to have as an input the area to the left of your point. So if you want 2% in the right tail, that means 98% is in the left tail.
Okay, and then if we were like trying to solve for the 98%, would we just use 0.98 then, or?
Yeah, if I asked you, what's the 98th percentile, then you just use 0.98. But if I asked you, where the top 2% is, then you'd have to realize, oh, the top 2% means the same thing as the bottom 98%. You always have to work with the area in the left tail.
Okay.
So tell you what, throw out a low number for me. Let's look for something over here. Pick a number. 5, 6, 3, 2, 1.
5.
5? Okay, cool. So I'll tell you what, let's work with the 5th percentile. I mean, how tall do you have to be so that you're taller than 5% of women? So that'd be P sub 0.05. That's going to be the 5th percentile. Now that's also the area in the left tail. So I don't have to adjust it like I did over here. Here I had to say, oh, top 2% is the same thing as the bottom 98%. Here I can just work with it directly, that's the 5th percentile. So you're right, norm inverse 0.05 in the left tail, that's what I want. So it's 0.05, and then the mean and standard deviation. So let's see what the 5th percentile would look like here. And I'll type in a 5 there. 5th percentile, you're right at 5 feet if you're in the 5th percentile of height. So does that help a little bit?
Yeah, it did. Thank you.
All right. Let's see what we got in the chat. So the question is, do we need to know both ways? And let me tell you in Spanish, no. No, you need to do it one way that works, and that's good for you, great. Now, maybe what I'll do if there's interest after I finish my presentation on this stuff, maybe I'll talk about how you can do this on the graphing calculator too. I just don't want to overwhelm people with all these different choices. And I think Google Sheets works pretty good, pretty fast, but it's up to you. And I will show you how to do it on the graphing calculator. One way or another, you're going to have to figure out how to do these things for yourself, finding these areas. Now, one other note here, kind of going back to our notational thing, that Z sub alpha. This is the 5th percentile. If I was to write it as, Z sub alpha somehow, remember Z sub alpha talks about the area in the right tail. So the 5th percentile was 59.98, I think it was. Yeah, 98. 59.98. What would this be in terms of our Z sub alpha stuff? Anyone want to tell me what decimal should I put here? Well, how much area is going to be in the right tail here?
Is it 0.95?
Yeah, 0.95. And it may seem simple, like, oh, well, yeah, big deal. The reason I'm harping on this now is because later on, Z sub alpha is going to come up an awful lot. And there's a lot of confusion at that point. It's like, wait a minute, does that mean there's 5% here, or what? Z sub alpha is always the area in the right tail. And we'll use it for other things too. We use it for chi-square sub alpha, those kind of things. So I just want to enforce it now so that way when you see it later, there won't be any confusion. Okay. We're looking all right on those. So there's two basic things you're going to have to use when you're using Google Sheets. One of them is if you're starting out with an X value and you want to get an area. So start with and end with, and then command. If you're starting with an X value and you want to end with an area / probability, then you're going to use norm distribution. If you're starting with an area / probability and ending with an X value, then you're going to use norm inverse. Those are the two commands that you're going to use. And if it's helpful for you to have it right here, let me put it here. You're going to type in your X value, mu, sigma, and then true to use norm distribution. And then if you're using norm inverse, you're simply going to type in the area in the left tail, comma mu, comma sigma.
When do you do the 1 minus?
That's if you're going to need the area in the right tail, then you could do 1 minus to get the area in the right tail. So it's going to kind of depend on the problem, but norm distribution is always going to be giving you area in the left tail. So if you need an area in the right tail, then you need to do 1 minus. So let's look at another example. Can I move this? You got this copied down? All right, no takers there. Let's look at distribution of quarters. So there's one like this in the book. This is kind of a nice one because we're going to do both of those commands that we just talked about. So let me see if I can't find this one in the book. I think it's the previous page here. Yes. After 1964, quarters were manufactured so that their weights have a mean of 5.67 grams and a standard deviation of 0.6 grams. So like before, let me suggest that we stop ourselves and write down some information that we know we're going to need right here. That is the distribution of quarters. So that's going to be X is distributed normally with a mean of 5.67 and a standard deviation of 0.06. Let's get back to the problem then. Some vending machines are designed so that you can adjust the weights of quarters that are accepted. If many counterfeit coins are found, you can narrow the range of acceptable weights with the effect that most counterfeit coins are rejected along with some legitimate quarters. So you might be throwing away some business, but at least you're not going to get cheated as much as essentially what you're going to do. If you adjust your vending machine to accept weights between 5.60 and 5.74 grams, what percentage of legal coins are rejected? Is that percentage too high? Well, let's take a look here. So again, I want to draw a distribution. And look, I can't make you draw these distributions, but I think that they're really, really helpful. So, oh, that was a good one. I don't have my little template today. All right, 5.67. And they asked us to try and find the weights between 5.60 or the percentage of weights between 5.60 and 5.74. So basically the area here. So, okay, we're gonna have to think a little bit, because if I remember my Google Sheets commands correctly, it's just gonna give me the area to the left of 5.74 when I use my norm distribution with that. But I don't want all of that area, I just want that area up to 5.6. So how do I get just that area in between?
Wouldn't we do like the normal distribution and then put that in and then minus the other normal distribution?
Excellent. So you're going to start here with this one and then subtract the area to the left of that one. So do it in that order, right minus the left. If you happen to do it in the wrong order, can anyone guess what would happen?
Wouldn't it just be negative?
Yeah, you'd end up with negative. And hopefully if you got something negative, you'd realize, oh, wait a minute, probabilities are between 0 and 1. and you realize you made a mistake. It's probably just that you subtracted in the wrong order. Just fix the sign. Okay, so why don't you see if you can't try and find those probabilities? So use your norm distribution, the mean, just give me the X value, then the mean, then standard deviation, then true. And see if you can't find that total area. So I'll kind of pause here for a minute, give you a chance to do that, and then throw your answers in the chat, please. So this first one is the area to the left of 5.74. And from that, I want to subtract the second one, which is the area to the left of 5.6. So again, the mean is standard deviation and true. Now you can do that all in one line, all in one command. I've broken it up into a total of 3 commands. So the first one is the area to the left of 5.74. And then what you can do is you can kind of get lazy. Of course, I don't call it laziness. I call it economy of movement. I can copy this into the next cell and then just edit this one value. I need to put in 5.60. Yay. Actually, you know what? Did I got these backwards now? Let's see. Oh, I think I edited the wrong one. All right, so this one should be 5.74. 74. This one should be 5.60. And then the difference, I'll put in the third cell. Third cell is just going to be difference between these first 2 cells, this one minus this one. And I've got it. Great. So doing as little work as I actually have to do to get that. Now you can type that all in one line. There's nothing wrong.
Can we go to the second cell for a second?
Sure. So the second cell, now I didn't necessarily need to type in the 60. If I do, it doesn't change anything. Although maybe you want to, maybe you don't. It actually doesn't matter.
Okay.
But let me highlight that again so you can take a look at that command. Actually, it's funny. It looks like even though I may have typed it in originally, it doesn't keep it. If I put in that 0 there, when I look back at the command, it drops it. Interesting. One way or another, are you able to get this value? 0.7566?
Yes.
0.7566. Thank you. Good to hear. Let me look back over here at this value here. So what that's telling me is that there's about 12.2% of the area underneath this curve in the left tail. So that's a 12.2 or 0.122, roughly speaking. Let's see if you can write down a couple values. What would that be? P sub what and Z sub what? See if you can't write down those 2 values there. And let's see, can I give myself a little more screen room? Not much. Yeah. So 0.12. What would those values be? P and Z. So some takers. How about the P? What should I put? What percentile am I talking about?
The 12th?
Yeah, the 12th percentile. It's separating the bottom 12% from the top, 88%. How about the Z value? So I think it sounded like maybe Don that gave me the percentile. How about the Z value? Remember, Z value is the area in the right tail.
Ooh.
how much of the area is going to be in the right tail if 12.2% is in the left tail? Or how would you find that? How would I find this area? Any suggestion?
100 minus 12.
Yeah, 1 minus the 0.122. So 0.879 or 878. So this would be Z sub 0.878, the percentage of the area in the right tail. Okay. How are we doing with these? You feeling comfortable with these kind of problems?
Yeah.
There's a part B to this. And I like the part B because it shows you both the different parts of the command that you have to use in one problem. One problem that you're going to confront in sections like this is starting out with the X value and finding the area or probability. The other one starts out with the area or probability and you find the X values. So let's turn our attention to that part B here. I gotta collapse that a little bit. So part B says, if you adjust the vending machines to accept all legal quarters, except those with weights in the top 2.5% and bottom 2.5%, what are the limits of weights that are accepted? Okay, so you're going to redefine things so that you have the top 2.5% and the bottom 2.5%. So not a bad idea to draw things. Let's do that here. Let's draw ourselves another distribution. I strongly suggest you do some drawings. It helps guide your intuition. You can look at things and say, well, wait a minute, that doesn't make sense, or this does make sense. So back to our distribution, that was X is distributed normally with a mean of 5.67 and a standard deviation of 0.06. So I'll put that here, 5.67. The problem was asking us to find these 2 points. The point in the right tail, so that 2.5% of the area is in the right tail, and then point in the left tail, that 2.5% of the area is in the left tail. So 0.025, 0.025. We've got to find both of those values. Well, are we starting out with an area and finding an X value, or starting out with an X value and finding the area? So are we using norm distribution or norm inverse for this part of the problem?
Norm inverse.
Yeah, norm inverse. Thank you. So now remember, norm inverse works with the area in the left tail. Now that's not too bad for this one. There's just 2.5% of the area in the left tail. So let's do that one right away. Equals norm inverse of 0.025, comma 5.67, comma 0.06. Now before I do that, before I type that command in, am I going to get a number that's less than 5.67 or greater than 5.67? What
Less
should I
than.
get? Less than or greater than?
Less than, because you're
Less than.
Less than. Thank you. It has to be less than, right? Because you're to the left of this. This is your 50th percentile. That's your median and your mode. So it has to be to the left of that. Let's do that command. And I think it's this one here. There we go. So it's norm inverse of 0.25, comma 5.67 and 0.06. So 5.55. How about on the other side? When I try and find this one. It's a good bet that I'm going to use norm inverse again, but what's changing?
Minus.
Yes, well done. So minus, so 1 minus that, what's the decimal value am I going to put in here?
0.975.
Thank you. Well done, Kelly. 0.975. Let's see what happens when I do that. When I put that in my Google Sheets, I get 5.79 roughly. Yay. And again, that makes sense. It's to the right of this. I expected something to the right of this because that's the 50th percentile. The 97.5 percentile would have to be well to the right of that. So both of those are making sense. Okay, are you feeling comfortable with norm inverse and norm distribution?
Yeah.
All right. Well, let me stop things here as far as the recording is concerned, and then tell you what's coming next.